Great. Thank you very much, Terry. And in response to your question, I offer a resounding yes. There are a number of important guiding principles that can help in our decisions about which reserves to include in a network. But before I go into those, let me just jump back to our initial decision-making framework and relate that framework to the exercise we just went through. So remember that framework had 7 key points or 7 key steps. And the first one was to establish an objective. So our objective was to maximize the conservation of 10 different species. In other words, our reserve network should include all 10 species. We then had a series of options, and those options represent our sites. These are our potential sites. There were 8 of those. And in each site, we used the variable of species presence or absence as our metric towards evaluating our objective. In other words, did the species occur in a site or did it not occur in a site? Again, that directly relates to our objective. Now, we didn't cover dynamics or uncertainty, but that's okay. These can get a little complex, and I think you see the value of them. But we did certainly have some constraints, right? We had the constraint of cost. We knew that conserving each area came at a cost, and we had a budget that we had to work at or below. Lastly, we combined all this information into a series of solutions. So we viewed our problem according to 3 different criteria. And using each one of these criteria, we were left with a network, and in each case that network included 3 reserves. So we had 3 different solutions then that we were working from. Let's talk about those guiding principles. We covered some ecology principles before, but I think there's some more general principles that can help in our approach to reserve design that incorporate many more aspects and are probably a little bit more adaptable to different circumstances. The first one is efficiency, and that really sort of makes sense and underlies much of what we've gone through already. We need to be efficient in our approach to reserve design. Remember again, we had a budget here. We had to work within that budget. We had to be efficient with our use of money. In other words, we're trying to achieve our conservation objective in the most efficient and cost-effective way that we can. So we can't simply just go out and conserve all of these different sites. That would be way too expensive. We have to maximize our dollar value here. We need to be efficient in the selection of our sites that achieve or allow us to achieve our goal within our budget. So efficiency kind of makes sense, but I think it's worth pointing out. Now, the second one is complementarity. And that's kind of a big mouthful here. But ideally, what we're trying to do is be complementary in the sites that we're selecting relative to our objective. So we're thinking here from a bigger perspective. We're thinking of our whole network being composed of a series of parts, and each one of those parts, or little reserves in this network, are complementing each other around this broader objective. So let's look at the data that we had here. If we consider site A, right, we know site A had the first 8 species, right? So if we were to select a complementary site to site A, would F be a good choice? Well, probably not, right? If we're trying to ensure that we've got all 10 species in our reserve network, F probably wouldn't be a good choice because we're duplicating some of the species that are already present in A, and we're not complementing site A because we are missing species 9 and species 10. They're absent. So this probably wouldn't be a good complement. I would argue that probably site B and site C represent good complements to A because they work together as a whole in terms of achieving our overall objective of ensuring coverage of all 10 species in our site. The next one here is comprehensiveness. So this is somewhat related, but our objective here is to be as comprehensive as we can. We have 10 species that are of interest. If we had a reserve network that only protected 9 out of those 10 species, well, we're not being very comprehensive, right? So comprehensiveness means ensuring that we're comprehensive in our approach, that our reserve network achieves what we're trying to achieve in a comprehensive way. So we would want to ensure that all 10 of our species are covered in our network. How about the fourth one? This one here is representativeness. Boy, I barely squeezed that on the screen here. Kind of a big long term. But I see this as kind of a finer scale version of comprehensiveness. And what do I mean by that? Well, let's say that one of our species here is the bobcat. This is a lovely bobcat photo taken in my home state here in Vermont. And imagine that bobcats are represented in our reserve, but we know that bobcats use 3 different types of habitats. So these probably represent different habitats. We know that bobcats use those. But if our reserve network only included this habitat, right? Even though there are bobcats there, we're not being representative in terms of the needs, the habitat needs of the species, because we're excluding our green and our red habitats. So being representative, ensuring that we've got those pieces, those resources, those key things that bobcats perhaps may need in the landscape in our reserve, means that we're not being representative. So we want to be representative. We want to include those things as best we can in order to ensure kind of a finer scale level of comprehensiveness. Does that make sense? And how about number 5? Number 5 here is adequacy. We need our reserve network to be adequate. And what I mean by that is our reserve network should have some long-term viability or long-term persistence. In order for it to be adequate in terms of achieving our goal, our objective, it needs to have some long-term persistence or viability. So in other words, if our reserve priority, one of our priorities was the bobcat, right? And after 1 year, bobcats went extinct from that whole system, then our reserve network is inadequate, right? It isn't achieving its mission, its goal over the longer term. So we can oftentimes ensure adequacy to some degree by being redundant in our site selections or adding replication to our decisions about reserve sites. And let's look at an example maybe to perhaps draw on those 3 last principles, maybe to clarify them a bit more. So let's consider comprehensiveness, representativeness, and adequacy in this design here that you can see. So here we've got outlined in white here, the broader outline, we've got a landscape. And within that landscape we've got 4 main habitat types, let's say. We could say the yellow here represents grassland, and the pink represents shrubland, and the green represents forest, and perhaps red represents desert. And within this landscape then we've got 3 different species labeled 1, 2, and 3. And so we've got multiple sites where each species occurs in each one of these habitats throughout this landscape. So let's say our reserve network included 2 reserves. It included this one here that's also outlined in white, and it included this one here that's also outlined in white. So this is our network, a simple one, 2 reserves. Are we being comprehensive? Well, I would say that we are being comprehensive because our reserve network does in fact include each species. So our reserve network includes all 3 species. So that's much like our example. If our objective is to ensure our network includes all our target species, we've done that. We've been comprehensive. Now, have we been representative? Well, each species occurs in each one of these habitat types. So to be representative, we should ensure that we have one site at least for each individual species in each habitat. So we do have one here in yellow, we've got one here that's also in pink, one here that's in green, and one here that is in the red, at least. And the same is actually true for number 2 and number 3. So we've been representative in terms of ensuring we've got coverage of the types of areas, the types of habitats that each species uses. Now, are we being adequate? Well, that's sometimes hard to judge in the long run, but again, one way that we can perhaps build some adequacy into our design is to ensure that we've got some replication. So in this reserve, we actually have not just one site where species 1 occurs, but we actually have 3 sites where number 1 occurs. We also have 3 sites where number 3 occurs. And if maybe we shift down to this reserve, we actually have 3 sites also where number 2 occurs. In other words, if we lost one of these, we wouldn't be out. If these were bobcat populations and we lost this one, we still have these 2 that are remaining, and that would, again, allow us to continue or allow us to ensure that we've got persistence of our objective here, or we've got the persistence of this species in the system. Make sense? So comprehensiveness, representativeness, and adequacy are important components to keep in mind. Now there's one final guiding principle here that I'll mention, and that is irreplaceability. Kind of a long term here. Sites that are irreplaceable are perhaps more valued in our reserve network versus other sites. So what do I mean by that? Well, let's look at our spreadsheet exercise here. We've got our 10 different species, and let me just highlight those in a different color. We've got our 10 different species here, and then again, remember, we've got our 8 different sites. So are there some sites that you might perhaps assign as being irreplaceable relative to others? Well, I might call site C an irreplaceable site. Why site C? Well, if you look closely, site C contains species number 10. And in fact, it's the only site that contains species number 10. In other words, if we lost site C, it can't be replaced. We would fail to achieve our objective of ensuring we've got coverage of all 10 species in our reserve network. So we could lose some other sites and still be okay, but if we lost 10, we wouldn't meet our objective. So this is a high priority site, or one that's irreplaceable. Okay, so let me just jump back now to our spreadsheet. And we left off, as you recall, with a series of solutions. And those solutions were based off of 3 criteria, right? So we had 3 different sets or 3 different networks that efficiently and comprehensively allow us to meet our objective. Now, as you may have noticed, there is another objective here, abundance, or criteria rather, that we didn't cover. So abundance is the number of individuals. So can we use the number of individuals of each species in each site to develop a new set of reserves, a new solution, a new network? In a moment, I'll jump you back to Terry, who will build an abundance model. She'll incorporate abundance as a new criterion and develop a new solution for you. But in order to do that, we need to know something about the relationships between species and habitat and how sensitive species can be to amounts of habitat with respect to abundance. So I need to cover a few things related to that species-habitat relationship before we can get back to how to go about estimating a reserve network based on abundance. And to do that, I'm going to just draw in a new species here. This is the toad-headed agama. It's a small lizard species that's sympatric with snow leopards in parts of Mongolia.
So let's imagine you're in the position of establishing a reserve for agamas and snow leopards somewhere in the South Gobi of Mongolia. Hypothetically, let's say you're in the position of trying to establish that reserve. The question is, how do you design that reserve that maximizes the abundance of both species? So it maximizes protection of both species by maximizing the abundance of those species. We know that perhaps they have different landscape sensitivities, and given that knowledge, how might you configure your reserve if you had that luxury in order to maximize abundance? So what are some things you need to know? Well, certainly you need to know their required habitat. So what is that unit? What is that thing out there that they really need? Now, in simple circumstances, we may have just a single habitat that's really important or critical, but of course there are situations in which there are multiple habitats. The other thing you need to know is something about how the number of individuals may change with habitat. So we need to know something about their sensitivities, but also something about this relationship between density and the density of the species and habitat.